Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in today's video, we will start the new chapter of second PUC, that is called as application of derivatives. Application of derivatives. Student, this is a sixth chapter in our second PUC. This is the sixth chapter in our second PUC. Student, in this chapter, there are many topics. In that, the first topic, very first topic is rate of change of quantities. First topic is rate of change of quantities. So in this topic I completely explained in our passing package series videos. So the link is already displayed in the description box. You can click onto that link to understand this topic. So next, let us go to the next topic of this chapter, that is called as increasing and decreasing function. Increasing and decreasing function. This is the second topic of this chapter. First topic is already discussed in our passing package videos. Link is, as I said, already it is present in description box of this video. You can click onto that link to refer this rate of change of quantities, problems and the concept. So student, let us start the today's video, that is called as increasing and decreasing functions. Very important one. So here, first let us discuss with the definitions of these two things, increasing and decreasing function. So if I have any function y is equals to f of x, if y is equal to f of x is any function, this function is defined in an interval x1 comma x2. Then if the condition is if x1 is less than x2, it implies f of x1 is less than f of x2. So in this case, we will declare that the given function is a strictly increasing function. Strictly increasing function, because I said it is strictly less than. That is, then f of x is strictly increasing. If suppose the function is like this and the condition is like this, and this is the first one, and the second one is if x1 is less than x2, implies f of x1 is less than or equals to f of x2. In this case, we will declare that the function is f of x is just an increasing function. It's just an increasing function. The reason I said it is strictly increasing here and here just an increasing function is here f of x1 is equals to f of x2. In some cases, these two functions are equal, but in this case, never be equal. For example, if I draw the graph of the strictly increasing function, this is called as first graph. This is my x-axis, this is my y-axis. If I take the graph, this graph continuously goes like this. It's a continuously increasing function. If suppose somewhere here, consider this is the x1, and definitely then this is my f of x1. And somewhere here, consider this is my x2, and then definitely this is my f of x2. These are the two values of x, or you can consider it as intervals. So here, if I see this, the graph is continuously increasing, and this graph is a continuous graph. Without lifting my pen, I draw this graph. So it is a continuous graph. And it is for every different values of x, the y will also be increasing. And here f of x1 is less than f of x2, as x1 is less than x2. Here x1 is strictly less than x2. And that's the reason f of x1 is less than f of x2. F of x1 is always less than f of x2. So that's why it is called a strictly increasing function. Called a strictly increasing function. Next, second graph. Here, if I have a function like this is x-axis, y-axis, origin. There is a function which goes like this, like this. Student, no doubt that this is also an increasing function, because this function nowhere it is decreases. Nowhere this function is decreases. Continuously it is increasing. But at some particular point, for example, if I consider this is my x1, or if I consider this is my A and this is my B, at A and B, the function becomes equal. The function becomes equal here. But after that, after B, the function is again increasing, and before A, the function is increasing. But when I consider this limit A to B, the function f of A is equal to f of B. That means f of A is equal to f of B. In the limit, in the interval A to B, the function is a constant function, because there is no changes here. Then it is increases. So this is called as normal increasing function, but this is a purely an increasing function. And both the graphs are continuous graphs. Both the graphs are continuous graphs. And student, in this increasing function graph, if I take any point on the graph, the curve, maybe here, any point, or somewhere here or here, if I draw the tangent with this point, just draw a tangent with respect to this point, then I will get an acute angle here. I will get an acute angle. The moment I said an acute angle, the moment I said it is an acute angle, that means the angle is lies between 0 to 90. It cannot be greater than 90 degrees. Otherwise, it will become obtuse. So the moment I said it is acute, it is between 0 to 90. And in 0 to 90, the slope of this tangent is greater than 0. Because you know, slope of tangent is what? Is tan theta is greater than 0. For every different angles, like we have seen in our first PC trigonometry, even in lower classes, tan 0 degrees 0, tan 30 degrees 1 by root 3, tan 60 is root 3, tan 45 is 1, then tan 90 is infinity. So from 0 to 90, the values are continuously increasing and it is greater than 0. So that means dy by d theta is always strictly greater than 0. So if you want to say any function is an increasing function, strictly increasing function, then we should prove that its derivative is greater than 0. Because if we draw the tangent, we'll always get acute angle. Now in this case here, sometimes we may get it is 0 also. Its derivative we may get it's 0. Because this from here to here, it is a constant function. And we know the derivative of every constant function is 0. So in that case, here if I am finding the derivative of increasing function, just derivative of an increasing function in some particular point, I may get dy by d theta is greater than or equal to 0. Here I wrote greater than or equal to 0 because it is a constant at some particular points. After that, it is a greater than only. But here in strictly increasing function, it is purely greater than 0 value. So student, this is about the increasing and strictly increasing function, but both are little bit similar. No need to get worry about that. Increasing and strictly increasing are totally different functions. No student. Both are logically equivalence functions. Both are approximately equal functions. The only difference is in increasing function we will take equal to 0, but here in strictly increasing function we will its derivative is strictly greater than 0. And in strictly increasing function, the condition is x1 is less than x2, which implies f of x1 is less than f of x2. And in increasing function, it is f of x1 is less than or equal to f of x2. It's the only difference. Next, now let us go to the decreasing function. Decreasing function. And as we discussed in increasing function, same case here also, but the function is instead of going upward direction, it comes to the lower direction. So if I have a function y is equals to f of x in the interval x1 comma x2, then function is said to be strictly decreasing if x1 is less than x2, which implies f of x1 is greater than f of x2. F of x1 is greater than f of x2. It is strictly greater than. Then f of x is strictly decreasing. In this case, f of x is strictly decreasing function. The first one. Second, if x1 is less than x2, it implies f of x1 is greater than or equals to f of x2. Here I wrote equals to. F of x1 is greater than or equals to f of x2. Then f of x is strictly, sorry, f of x is decreasing function. It is decreasing function. So these are the just basic definitions of decreasing functions. Now let us see the graph of this. We have a function. This is my x-axis and this is my y-axis, and it is 0. This is the graph of the function y is equals to f of x here. And let me call this is my x1, and somewhere here my x2. These are the intervals on x-axis. So this is my f of x1, and this is my f of x2. Now, student, we can easily see here the x1 is less than x2. x1 is less than x2, no doubt about it. But in case of f of x1 and x2, our f of x1 is greater than f of x2. The value of y is greater here compared to here. So this is purely called a strictly decreasing function. Strictly decreasing function. Now what happened in case of just decreasing function? This I will call as the first graph. I will here the first graph, and draw the second graph here. Y-axis, x-axis, and it is origin 0. So here the graph is decreasing. The graph is here decreasing. But at some particular point, the graph gets like this. Again, after this point, it starts decreasing. So here, if I call this is my x1, and this is my x2, obviously x1 and x1 is less than x2. And here, f of x1, here I have f of x2. But in this limit, x1 and x2, for some particular point, or at some particular point, this function is equal. Or I can call this is A, and this is B. Then at this point, it is a constant. It is neither increasing nor decreasing. It is just a constant, straight line. So here, f of A is equals to f of B. So this is the only difference in strictly decreasing and the decreasing function. And both the graphs, whatever the graph I drawn here, both the graphs are continuous function graph. And in this case, whatever the tangent I will draw, wherever you draw the tangent, maybe here, or somewhere here also, the tangent I draw here is the angle for this is always greater than, I draw the tangent for this particular point. So here, whatever the angle I am getting is an obtuse angle. Is obtuse angle. So here, its derivative, that is dy by d theta theta is the angle here, is less than 0. dy by d theta is less than 0 because I said it is an obtuse angle. And we studied in our trigonometry our tan theta, that is dy by theta is tangent. So tan theta is negative in second quadrant. Tan theta is always negative in second quadrant, so that's why its derivative is less than 0. In case of just decreasing function, its derivative will be less than or equal to 0. Derivative is less than or equal to 0. Okay, students, after the definitions of increasing and decreasing functions, let us go to the another topic, which is very small topic related to increasing and decreasing function, that is called as derivative test. Derivative test. Student, let me quickly revise what is increasing function. So student, in increasing function, if x1 is less than x2, which implies f of x1 is less than f of x2. Now we can call this is increasing function. This is the first one. Then second, what we discuss is decreasing function. If x1 is less than x2, which implies f of x1 is greater than f of x2. This is a decreasing function, isn't it? Now, how do we test this? How can we verify our problems? Then in our problems, the basic concept which we apply is, we will just check the function with its derivative. As I discussed in its definitions, if the derivative of function dy by dx is greater than 0, any function whose derivative is greater than 0, obviously then the function is increasing. The function is increasing, or you can call it as strictly increasing. Obviously, if it is greater than or equal to 0, it is just an increasing function. But in general, it is increasing function. If its derivative, if any function whose derivative dy by dx is less than 0, the function whose derivative is less than 0, then function is a decreasing function. Decreasing function. So, derivative test says that derivative is greater than 0 means obviously it is increasing. Derivative is less than 0 means it is decreasing function. So, student, here, if suppose the derivative is 0, constant, then in that case it is neither increasing nor decreasing function. It is neither increasing nor decreasing function. You can call it a function is a constant function. As I explained you in increasing and decreasing graph, somewhere if some function is in some particular point, if it is not changing, then it is a constant. Now, after this, the derivative test, there is one more small topic which is called as monotonicity or monotonic. Now, we'll discuss the monotonic function. monotonic functions. So mono, this is a very old word for us. Mono means single, single decision, single conclusion. It will not give any confusion to us. It will give single answer. That is, a function f of x is either increasing or decreasing, then it is called monotonic function. Either it is increasing or it is decreasing, but not both. Then that kind of functions are called as monotonic functions. For example, if you see a graph, simply I will take one general graph. If it is an x and y axis, so if you have a graph like this, this is A, this is B, and here it is C. The student, there are three values on x-axis here: A, B, and C. So here in an interval A to B, in the interval A to B, this function y is equal to f of x is increasing function. Is an increasing function. As you can see, the values are increases. But in case of the interval B to C, the values are decreases. Function is decreasing. It is decreasing. You can see the values are decreases here. In the interval, it is B comma C, and here it is in the interval comma B. So, in the interval A to B, the function is purely increasing, that is strictly increasing, and in the interval B to C, the function is strictly decreasing. Now, my question is, what happened in the interval A to C to the same function? Y is equal to f of x, that is same function. What happened when we take the interval A to C? Now, student, here it is not a monotonic. Monotonic says that either it is strictly increasing or it is decreasing. If both comes, it is never a monotonic. This is a monotonic function from A to B, and from B to C also it is monotonic. But when it comes to A and C, that is A to C, it is neither increasing nor decreasing function, because it gives two conclusions at this interval. Now, if this kind of situation comes, obviously this kind of situation comes in many places. For example, I will take one more example. We have seen sine function, very much familiar to all of us. Sine graphs look like this. This is my origin. This is not +1, this is -1. Since here the graph is increases year to year, Again, from here to here it is decreases. Here to here it is decreases. Then again here to here it is increases. So it is increasing, decreasing, increasing, decreasing is there. Now, if this kind of situation comes, what exactly we should do? Student, in that case, we should find the intervals. We should divide the intervals. If I said, for example, if it is 0 to, this is pi by 2, pi, 3 pi by 2, it is 2 pi and it goes on. So student, if I suppose same thing, if I take in the limit 0 to 2 pi, what happened to the sine function? Y is equal to sine x. So I cannot give any conclusions here. It is both increasing and decreasing is there. If I want to give a proper conclusion, then I should break its interval and I should show that where exactly the sine function is increasing and where exactly the sine function is decreasing. So what we will do for that is, we will divide the intervals. As I said here, if I am getting confused, if I am not declaring from A to C, then I will make it as A to B, then B to C. In this intervals, I can easily define, as we have seen here, it is A to B it is increasing, B to C it is decreasing. But A to C, it's not possible. So to divide the intervals of any function, we will use a wavy curve. Wavy curve method. We use wavy curve method. Now let us discuss what is wavy curve method. Then we will go to wavy curve. So in this curve we will generally basically use to find the intervals. If you have a bigger interval, that is, for example, if it is 0 to 2 pi we have, then to break the intervals, we will use the help of wavy curve. We will make the 0 to 2 pi is in a small intervals. But how to make that? Where exactly we should make the intervals? Then solving the function is very important. First thing what we should do is, we should find the critical values of a function f of x. What is critical value of any function? The critical value is value of x or theta, whatever it is, the value of x, which satisfies the equation. It satisfies the equation value of x, which satisfies the equation or function guidance. After finding the critical values, second step is, we should draw a number line. In this number line, towards our left hand side it is minus infinity, towards our right hand side it is plus infinity, and whatever the critical value we got, that is the value of x, we should plot it here between minus infinity to plus infinity. If it is a positive value, we will mark somewhere near to the positive infinity. That's considered is A. Then with this one critical value, I got two intervals. One is from minus infinity to A, other is from A to plus infinity. If the given function is positive function, if the highest power of x in any function is positive, then we will mark this plus and then minus, plus sign minus. Or we can call it as, if the derivative of that function is greater than 0, we will mark that plus and minus. Alternate sign we should keep giving. If you get two critical values, you will get three intervals. So again, the procedure remains same. Right hand side interval it is plus, minus, then plus. Wherever we mark plus, there the function is increasing. Then the function is increasing. And wherever we mark minus, it is decreasing there. Function is decreasing. As I said, if you get two critical values, this is plus infinity, minus infinity. One is got A here, they got B here. Okay, right, B and B here. So if I am getting two critical values, then totally we get three intervals. The open interval. So the first interval is minus infinity to A, second is A to B, third is B to infinity. So if I mark this is plus, definitely this is minus, this is plus. So here the function y is equal to f of x is increasing at two different intervals. Then how should I write exactly further? Is increasing in the interval minus infinity comma A union B comma infinity, which use the symbol union, because we need this as well as this both the intervals need, so we will take union, and it is decreasing in the interval A comma B. Decreasing in the interval A comma B. Student, this is the procedure we will follow in radical. So what exactly we'll do? First we'll find the critical value, then we'll draw the number line, and the number line explains are minus infinity and plus infinity, and we'll mark first the critical value on the number line, then plus sign, minus sign. We will mark wherever we mark plus sign, that particular interval the function is increasing, and wherever we mark negative, in that particular interval the function is decreasing. In case of two or three or more intervals, then wherever it is a plus sign, there will take union, and wherever is the negative sign, there it is also union if it is more than one interval comes. If single interval comes, then we will write the particular interval. So student, this is the basic information you people should have before we start solving the problems of increasing and decreasing function. Okay students, now let us go to the problems. So we will take the first problem. The first problem says that prove that the function f of x is equals to bx plus 17 is an increasing function. Is an increasing function. In R. R is set of all real numbers. Solution. Here the function is a linear function. Bx plus 70 is a linear function. In this function, first let us check with the derivative test. If its derivative is greater than 0, then the function is an increasing for every value of x. Differentiate f of x with respect to x. Simply we will call it as f dash of x. So coefficient as it is, derivative of x is 1 plus constant is 0. So its answer is 3. 3 is greater than 0. 3 is greater than 0. So the moment its derivative is greater than 0 here, what happened? So the given function is increasing function. Since f dash of x is greater than 0, then the function is increasing. Function is increasing function. Let us go to the next problem, similar to this. Prove that f of x is equals to 2x cubed plus 3x square minus 5x plus 6 is an increasing function. This time we have a cubic function, cubic equation, and we should prove that it is an increasing function in real numbers. Does not given anything, then we will consider it is real numbers. Its solution is given f of x is equals to 2x cubed plus 3x square minus 5x plus 6. So let me differentiate this. Differentiate f of x with respect to x. What do I get? F dash x is equals to 2 into x cube is 3x square plus 3 into 2x minus 5 into 1 plus 0. Derivative of constant is 0. Derivative of x is 1. Derivative of x square is 2x. Derivative of x cube is 3x square. So finally, its derivative is 6x square plus 6x minus 5. For every value of x given here, since it is a square, so purely it is a positive quantity. And here, okay, this may be a negative quantity. For positive, it is positive. For negative values, it is negative. Here it is purely a negative. But here, this square is multiplied by 6. So we can consider that this is always a greater quantity compared to these two negative things. If at all we are giving any negative sign. So at the end, overall, this derivative is greater than 0. So the moment we said derivative is greater than 0, the given function is increasing function. Therefore, f of x is increasing function. of x is increasing function. The student, I will stop here. Next class will continue problems based on increasing and decreasing function, as well as we'll solve how to find the intervals where the function is exactly increasing and decreasing functions. So student, in today's topic, you have any doubts, please put your doubt in comment box, and to help other students, don't forget to share our videos. If you are new to our channel, subscribe our YouTube channel. Thank you.